Welcome to the second video in video module 6, and this is the first model development. And as I said, there are two of these for the implementation for the case study 3 OBI electronics. One quick note here, this process of building this model is going to appear a lot more linear than it actually is. So what you see is the end product of me going through the implementation phase. So I start with the conceptual design and the implementation plan that we developed in class, and then I implement it. But there's a lot of feedback in that process. You go back and change the design, you modify your plans, and so on. So it's not a linear process from conceptual design to implementation plan to finished. And so I just wanted to make sure to not give the impression that I just sat down and did this in the same sequence of activities that I recorded in the video. I guess I could have recorded the entire process. Would it be kind of like a reality TV show? First of all, it'd be a lot longer than this one is, and probably quite a bit more boring. So recall our system, we have 4 stages and we're processing orders. And for these two, the assemble and finish stages, we decided we were going to define this work center workstation concept where we have the stations that belong to a work center being fed by a transfer node. So once we have this definition, what we're going to end up doing is we're going to use that definition even on the kit and the package. So we're going to define a generic workstation as being a transfer node and a set of stations that belong to that work center. So here we are in Simio, and let's get started. So the first thing I'm going to do here is I'm going to go to resource and create my subclass. Okay, note this is an interruption of the video because I just made a mistake. I subclassed the resource where I meant to subclass the server. So instead of fixing it here and re-recording everything, what I'm going to do instead is leave the mistake and show you later on where I actually fixed the mistake. And so keep note, if you're following along, that this should subclass the server, not subclass the resource. We talked about this in the design, and I'm going to name this AE server for OBI electronic server, because I know I want to set that up to use the task sequence and so on. So I'm going to have that custom object. And next we'll go back to our model, and because we know we want to have our model be data generated and data driven, I'm going to go back in and set up my first table. And the first table that I usually set up is the resources table. So we set up resources, and we have the properties, we have the object type, or the object instance. I'm just going to call this R name, resource name. I know I need to specify the type, so I'm going to go ahead and put in the object type, call this guy O type. And the two locations, so the plain locations of X and Z. So I go back and add 2 real properties, XLoc and ZLoc. Second one is a real, ZLoc. So I have my basic table structure set up, and now I want to specify that I want this to be auto-created. So go back to my table default value instantiation and make that auto-create. And then the first thing I try to remember to do is go ahead and auto set table reference. And I try to do that first because I forget it if I don't do that first. Then we can go back in and specify the type, and then specify my 2 locations, XLoc and ZLoc. There we go. So our table's set up. And now we can build some instances. So for example, if I want to have my arrival source, because I know I'm going to have arrivals happen at I'm going to have a table-based arrival structure that we've seen many times before. So I'll just go ahead and place that in. And note now when we, where's my instance? I guess I wasn't at 0, 0. There I am. Now I'm at 0, 0. There it is, my arrival source. Don't know how I got so far away from 0, 0, but nevertheless I did. So we can, as you remember, move this around. And when I do that, it links back to my 2 location columns. So what we would now do, and what I did do when I set this up, is I typed in all of the other objects in our system, resources in our system. I'm not going to do that in the video. Instead, I'm just going to paste these in from Excel. I'll leave this up here a second so that you can pause the video if you want to create your own Excel to do that. And so we just grab these guys, Control C, and let's get rid of the sample one we had, and then paste those in. And so now when we go back to our facility, you can see that we have the layout set up similar to what we saw in the project model description, where we have the kitting here, we have the assemble here, we have finish here, and we have package here. And also note that we have these workstation definitions. So we have kit is actually the transfer node, and kit 1 is the station. Assemble is the transfer node, assemble 1 and 2 are the stations, and so on. And so go back and see those were defined in our resources table. We also have the changeover operator, because remember, the sequence-dependent setups for the finished station require an operator. So we went ahead and generated that operator from our initial table. So next we'll set up the materials table. And so recall that we are going to use material elements to represent our modules, the finished goods, as well as the raw materials. And so we are going to create material elements for all of the finished goods, module A, module B, module C, along with all of the raw materials. So let's go back to our model here and create the table. So let me go, if I can find Simio here, there we go. So I'm going to go back in and I'm going to add another table. And so I'm going to call this table materials. Oops, spell it right. Materials. And the columns that I'm going to have, the first one I'm going to have is my element property, which is a material. And so I'm going to call this mName. And then I'm going to define a string property called mClass to represent, so I can use to differentiate between finished goods and raw materials. So this is going to be mClass. And then I have an initial quantity that I have in stock, initial quantity. So let's just call this initial quantity. And now the next thing I'm going to do was most definitely not linear. So when I set up this table, I didn't add this field in right now, but I'm going to go ahead and add it in here and just, again, recognize that I came back into this after the fact, and I'll talk about why I did that in a little bit. So what I'm going to do is I'm going to add a Boolean property, and I'm going to call this Boolean property assume infinite. And what I'm going to use that assume infinite column for is so that I can turn the material requirements on and off. Because remember that we have these bill of materials requirements, and during debugging, sometimes I want to ignore those. And so we also know that if I go back to my definition and say pull up a material, that I have this option here, this advanced option that says assume infinite availability if. And so essentially what we're going to do is we're going to allow the user to turn this on, to turn this infinite availability if through the table. Okay, so we're going to assume that. So let's go back to our table, and there we have that. So the next thing I'm going to do is go back in and make this auto create. So elements are handled a little bit differently than object instances. So I'm going to go over to my auto set table row reference. I'm sorry, reference type instead of reference is going to be create. And then I'm going to set the auto set table row reference to true. Now, to do our two initial properties, so we have this initial quantity, and we have that assume infinite property that we'd like to set when we create, or we want to use the two table columns to specify those values for the material elements that we create. So setting these initial property values is also a little bit different than we saw with object instances. So I'm going to pull the repeat group editor up right here, and we have two that we'd like to set. The first one is really straightforward. I want to set this initial quantity, and the property that I use is initial quantity. So that's the property value, initial quantity, and we just set this value equal to the table name, initial QTY. Now note here that for the materials element, we have to specify the table name, whereas when the object instances, we didn't. So I'm going to stop here right now, and then we'll come back and do the second one in just a second, because as you should know by now, I like to test things as we go. So I don't want to add too much. So let me just make sure I have that set up right. And so now when I come in, I'll just create one. Let's just call it M1. And then we want to have this be finished goods. And let's say its initial quantity is 12. right? And so then I go over to my definitions, and you can see that we created that M1. And what I'm looking for here is to make sure that this initial quantity got set correctly. And you're going to see why that's important here in just a second, because this initial quantity is really an easy one to do, but the second one is not quite so straightforward. So let me just go back and delete that one, and then let's tackle this, assume infinite. So to do this, I'm going to just go ahead and implement this, and then I'm going to come back and discuss it. So go back here and add the second row. And so the trick here is that the property name is not assume infinite condition if. Instead, it's assume infinite availability condition, right? So it's not the if, but instead it's the condition. And then we set this equal to the materials assume infinite. Okay, so let me go back in and try this real quick, and then I'll go back in and explain what's going on here. So we'll just skip that M class right now, and we'll put our 12 there and assume infinite here. Jump over here and look at our create, and that, sure enough, you can see that here. So we've got the table reference for initial quantity, and then we have the table reference here for assume infinite availability if. So naturally the question, well, I hope naturally the question you're asking yourself is, how do we know that? So in other words, when we look at this, let me remove this element so I don't forget. When I set this value, how did I know that initial quantity is pretty easy because it's just the property that I see, but for this assume infinite availability condition, you might be thinking, why isn't it infinite availability if, which is what you saw before? And since it's not, how do I find this? Well, there's a couple of ways to do it. The easiest way is a little trick where we use the create table from schema to create a temporary table. So what I'm going to do is I'm going to go to tables and say add table from schema, and I want to add a materials table. And what I want is the parent for material. Okay, so when I add that, it's going to create this new table, and what the table is pre-configured to match the property values for the table element, for the material element. So I'm just going to scroll over here and look for right here. So here it is, assume infinite availability if. And if I choose that, you can see that the name, the property name, and the display name are different. So what I need is, here's what I see, assume infinite availability if, and here is the property name. So you can see assume infinite availability condition. So in order to figure out what that property name was, I just added the table from schema. Then I don't need the table anymore, so go back in and remove the table, and now I have my material table set up. And so as we did with the object instances, I would then enter all of the materials. Again, I'm not going to do that either. I'm just going to go into my materials that I've sort of pre-built and then paste those in. And you can see that I don't have this assume infinite availability column here. I'll just let that default to its default value. But I have my 3 finished goods, module A, B, and C, my 4 components, which are raw materials, my 4 paint colors, and my 3 boxes. So I'll just go in and copy that, go in and hit escape, paste those values in. And now we see assume infinite is set to the default value of false. So if I go back to my definitions, there are all of the material elements that were created. And if when I'm running my model, for example, if I want to ignore the material constraint on, say, component A, I can just check that box and then run the model. And if I run out of component A, it's going to, the model's going to continue to run, and that inventory will go negative. So now that we have the materials defined, I want to go back in and add the routings for our finished goods, module A, module B, module C. So if we remember back to our table structure, we have our materials table, and that is connected to our routing table. And so the routing table defines the sequence of processes. So when we have a material, it's linked through this foreign key material name to a routing. And the routing specifies a node that's linked back to the resources table. And note again that this is this dash line because the node can't be a foreign key. The node has to be a sequence destination, because when we define the sequence destination, that's what allows us to route by sequence. And so let's go back and add that, and then we will talk further about that as we do that. So let's go back in, and I'm going to just manually add a table here. I could add a sequence table if I want, but I want to demonstrate doing this the manual way. So I'll go back in, and we're going to call this one routing. And also from our ER diagram and from the class, hopefully you remember that we need to have a unique identifier here so that we can link to the bill of materials that we'll cover here in a little bit. So I'm going to define a routing key, string state. So I'm going to go back and, oops, I want that to be a property here. So a string property, and I'm going to call this routing key. If I can click on it, routing key. And then I'm going to make this the column key. Okay. Then I'm going to add my material name, and my material name is then my foreign key back to the materials table. Jump back here, and you can see that I've already forgotten to set this as column key. So good thing I came back and looked. So we need that column key in order to be able to set the foreign key here. So I'm going to add a foreign key property and call this mname. And then we're going to have its default value be materials mname, and so now you can see the foreign key there. Then here's where our sequence destination comes in, because we're specifying where this is going. So I'm going to go to properties, and here's where I don't do a node. So I don't specify a node object here. Instead, I specify this sequence destination. Where is it? It's somewhere down here. There's sequence table. There it is, sequence destination. And I'm going to call this node. And one more thing I'm going to do is I'm going to go set this property to accepts any node to false. Its default value is true, and what that means is you can have any node in your model. But what I want to do is limit this to where the nodes have to be associated with an object. So let's just click on false there, and now we have our node set up. And then the last thing we're going to set up is our 3 processing times. So we have, remember, setup time, process time, finish time. And so these are all real properties. So I'm going to go back into real property here and set this to setup time. And then set the unit type to time and the default units to minute. And then we're going to do the same thing for process time. So real process time. Set it to units of time. Unit type of time and units of minutes, and then finally finish time. So go back in and say finish time, and its unit type is time, and its unit is minutes. So then we could go back in and add our routing. And so if we wanted to, I'm just going to paste these in again so you don't have to watch me put all of these in. So just go back to my Excel, and here are all my routings, and you can see that I have module A right here. These first 5 are module A, and so our routing keys are defined using our sequence. So we have our sequence of 10, 20, 30, 40, 50, and so we're going to define those guys. So let me just select all these right here, and then paste those in right here. Again, ordinarily you would, why don't I have module A? Let's see here. Where key not found? Oh, I didn't set my column key. So we set the column key right here. I had defined it as a foreign key, but I had forgotten to set the table key. And so that's why you were seeing the errors, because it didn't know where to look. It saw the values, but it didn't know which column to look into to verify the consistency. And so now when we look at our materials, if we go choose module A, there's 10, 20, 30, 40, 50, and it goes kit, assemble, finish, package, ship, and then the corresponding times. Similarly for module B and module C. And then if we look at our other components, there's no routing records for those. So now we have the resources set up, we have the material set up, and we have the material routing set up for our finished goods. Okay, so now that we have our routings defined, let's go back to the facility view and let's set the output nodes to route by sequence. And so what I'm going to do is I'm going to select my order arrivals and make that by sequence. Then I'm going to skip kit and assemble and finish the transfer nodes, and I'm going to come back to that in just a second. But let's select the other one. Let's select, or one of the other ones. Let's select assemble one. And here's where I discover the error that I made earlier in the video, is I'm expecting this to be a server so that I can select its output node. And I discover here, oops, when I go to AE server, I subclass the resource instead. Well, here's the beauty of using custom objects. So I'm going to go back in, and what I'm going to do is I'm going to delete AE server. All right, so I'm just going to delete that custom object. I guess I got to go here and do delete. And then it's going to change everything in my model. You can see now if I go back to assemble and all of that, these are all set to the AE server, but AE server doesn't exist. So now I'm going to go back in and subclass server, and I'm going to name this AE server. So just right click here, rename AE server, go back to my model. Oops. Don't want to delete that. Then I'm going to delete all my resources. So delete all the resources. There we go. Now all of our routings are messed up because those resources don't exist. But I go back into my Excel where I have all of this tracked, go to my resources and grab those, and then go back in and paste them in. And now you can see everything, all the errors went away because now I have my resources. I need to set this as column key. I forgot to do that. Go back to my model. They're all set up. Now when I go to assemble, it's now an AE server, and the AE server is a subclass of server, exactly what I meant to do. But you can see this kind of mistake happens all the time, is that you subclass the wrong thing, or you make some mistake, a relatively simple mistake, and you get further down the road in the model. But because I used a custom object, and because I had all of my data stored in a data table, and in this case I had it in Excel, it was really simple to go back and fix that error. So what we were in the middle of doing is we were saying, I want to go to and set this to route by sequence. So I'm just going to go set my destination type to by sequence, and then I'm going to right click and do update AE server defaults from this. And so now when I go look at kit, it's by sequence, assemble 2, it's by sequence. So all of the instances of that class AE server are updated accordingly. Now, back to kit and assemble and finish. Why aren't these routed by sequence? Well, for these, we need to select from list, right? So remember when you go to assemble, we want to select one of these two. When I go to finish, I want to select one of these two. And for package and kit, we want to use the same concept of a workstation. So we're actually going to select from the list, but the list is only going to have one element. Okay, so let's set that up. So I'm going to go to kit, and what I want to do is I want to select this input node and then right click, and I want to add to node list, and I want to create a new node list. So we'll call this kit list. And so when I do that, note that if I go back to my definitions and list, that was just a shortcut for creating a list called kit list, right? That selecting and then right clicking is just a shortcut. So now I can go back to my kit and say, rather than for destination type, I want to select from list. I'd like to select from kit list, and then my selection goal is going to be smallest value first of the overload. So it's going to select, well, I only have one in the list, so it's a pretty boring selection for this one. Then we're going to do the same thing for assemble. So I'm just going to choose both of these and create add to node list, create new node list, call this assemble list, and then go to assemble and make it select from list. And now the node list is assemble list, selection goal, smallest value first, and that overload's already set. Same thing for our last two stations, our last two work centers. For finish, select all three of those, and now add to node list, finish list, go to the finish transfer node and select from list. I want that to be finish list, and I want my selection goal to be, oops, not random, smallest value first of overload. And then last but not least, package, again, a singleton, but we will define a list anyway. So we will create a new list here and call this guy package list. And then we will go back into a package transfer node and select from list and package list, smallest value first. Okay, so we now have a kit list, assemble list, finish list, package list, and we have the corresponding transfer nodes set up to use those lists to select what's likely to be, based on this overload function, the next available station. So you might be wondering right now why we didn't create a custom transfer node object. So we have the very same process in each one of these, and we're going to revisit this later. The short answer is we could have done that, but we would have had somehow been able to specify the node list in the resource attached to the resources table. So again, we will revisit this when we get to the ISA 95 template. For this model, I thought it was just easier to do these all individually. So the next thing we'll do is we will set up the task sequences for our AE server object. So go back to our data and recall that the routing table, each one of our routing rows, included the setup, processing, and finish time for the corresponding process, or the corresponding work center for each one of our modules. So I'm going to go back to the facility and we'll just choose one. Let's do a symbol one like we did before. And I can just change the process type to task sequence, pull up the repeat group editor, and we need to add 3 tasks. We're going to add task 10, which we'll call setup, and its time will be the routing setup time. There we go. And if we don't see the time units because we specified that in the table, then I'm going to add another time, or another task, 20. So we'll just use the sequence number. This was process. And we will, for now, we'll just do routing process time. Now remember that the process time is per module. So we will eventually come back to this and multiply this by the quantity in the order, but we don't have the order set up yet. So we'll leave that for now, but make a note that we have to come back and do that. Pretty sure I'll forget that, but we'll give it a try. And then we do 30 and we say finish. So go back and set the time to routing finish time. And so now we have our task sequence is setup, process, routing, setup, process, finish. The setup and the finish are per batch, so those times are common. And the process time is per module, but we don't have the module set up yet, so we'll come back and fix that. So now we have that set up. We can then right click and do update AE server, and then we'll just pick another one at random, finish 2, and look at its task sequence. And now its task sequence is set up, as are all of the other instances of that custom object. So at this point, I'm getting a little bit nervous because I've put a whole lot of features in, but I haven't been able to do any real testing. So I want to find a way to do that at this point. So what I'm going to do is I'm going to go back in and add my order table. And once I add my order table, I can then run a test order through before I do anything like sequence dependent changeovers or bill of materials or any of that stuff. I can just test the basic structure, which will be the task sequences and the route by sequence. So let's go back to data and let's create a new table, and we're going to call this orders. And our first column is going to be a date time, which is going to be our arrival date. So let's see, this is going to be date time. I'll call this arrival DTG, and I'm going to set the initial time to be the time that I want my model to start. So let's start our model. What is this set up for? 2/28/22. We'll make it 7 a.m. 7 a.m. on 2/28/22. And so I can go back to my data and make this default value. Make this default value 2/28/22. If I could type, at 7 a.m. So we have our arrival date, then we have a unique order ID. So this is order ID. And we will make this column key. Then I need to specify what's in this order. So we need our our foreign key back to our materials. So I'm going to add a foreign key property and call this mname. Go back in and specify which table. So this is our mname property. Then I'm going to add the quantity. So go back in and add an integer value for quantity, QTY, quantity. And we'll go ahead and put the due date in. We know we're going to do that, so we will go ahead and put that. So let's do date time, due date. There we go. And then, as we have done before, I want to make sure that if I have orders that arrived before the model started, before the run started, that they're actually started at time 0. So to do that, recall we use an expression, and we'll call this release date. And its default value will be max of orders arrival date and 0. And so if it arrives before the model starts, that number will be negative. So now we have the arrival date. So let's go ahead and put an entry in. So let's put an entry in here. So our arrival date is, I want that to be 7/28/22. 7/28/22. Wow, that's a mangled it. 2. Can't type today. 7 a.m. So 7:02. Okay, let me get that straight. So you see why I like using Excel to paste things in. It's sometimes hard to get the exact thing in the table editor. So there we go. So 7/22. 28. 7/28/22 at 7 a.m. Go back and make sure I've confused myself now. 2/28/22 at 7 a.m. Wow, 2/28. There we go, 2/28/22 at 7 a.m. We're going to make this order 1. And we'll make this for module A, and let's make it 10 units. So we have 10 units of model A. We don't need to worry about the due date. One thing that I did forget, though, is completion date. So let's go ahead and add that in. So I'm going to go back in. Instead of a property, remember, this is a state because it's written. So we're going to go back in and write and call this completion date. Completion date. And so we'll write that back at the end. So we have one order 1, that should arrive at time when the model starts. It's going to be module A, 10 units. Forget about the due date. Release time should compute, and then we will record the due date. So now we need to set our source to use this table. Go back to our arrival table and say, I want the mode to be arrival table. And then it says, okay, well, what arrival do you want to use? And here's where you have to remember that we want to use that release date. So we do that. And now I also want to go back in and set my run length to be indefinite. Since we have an arrival table, and once we set that to indefinite, it will run until the last order is finished. And the last step here is go back to my ship and write that completion date. So state assignments, when an entity enters, and this is going to be orders, completion date, and it's going to be time now. So we write that as time now, completion date. Okay, so I'm going to then go create, I guess I didn't create my orders entity yet, so I'm going to do that. Here's my order. And then set my arrivals to type order. And then I'm going to go back in and have my dynamic text so that I can see what that order is. So I'm going to go choose my instance and say, this is orders, order ID. Did I get that? Orders, order ID. Right, so we have that. And so what happens is when an order arrives, it has a row reference set to this row. It can then pick off the order ID. It then has a link to the material table. So it chooses the material. Once it has a link to the row reference to the material table, it then identifies the sequence here. And so now when we run, we hold our breath, and we have a problem. So let me go back and see what the problem that we have here is. So I'm going to go here. All right, so you didn't get to see me do the debugging, but what it looks like here when I run, so let me just run the array here so you can see this, and it's saying, okay, I got here, and it doesn't know how to do the table resolution, right? And so what that means is that we haven't set the table row references properly, so for the process. And so the table row reference actually gets set from the arrival table, and what I think I forgot to do is set this to be by sequence. And so when the entity first left, the sequence was messed up. So if I go back and say route this by sequence, and then these are all routed by sequence, and now when we run, that error goes away, and now we can see it goes to kitting. And then I guess if we increase the speed here, I don't know how long this is going to take. I don't remember what the times were. That's not enough. Let's increase it a little bit faster. And then there it goes to assemble, and then it should go to finish and package. But let's just go ahead and fast forward and then go back and look at my data orders. And so we in fact wrote that output. So it made it all the way through the sequence. If I want to see what actually happened, of course, I go back into my model. I can go back in and stop it, and let's set it for interactive logging. So I go to the run option and advanced options, enable interactive logging. And then I go and set all of my AE servers. Remember to log resource usage. And then again, don't forget to update from this. And then we'll just look at a random one and make sure that it worked. There it goes. And then I also want to go ahead and do this one for the secondary resource, which we haven't used yet, but undoubtedly I would forget to set that. So we want to set that to log resource usage equal true. Then I can go to my planning, and you can see there are all of my assemble steps. I'm sorry, all of my work centers. And when I create plan, now we can see the plan went to kitting, to assemble one, finish one, and then to package. And if we open any one of these, we can see the setup, processing, finish. And as promised, I forgot to go back in and edit that process time. So the processing times now are single values as opposed to per unit. So let's go back in and fix that. Go back, let's go to Kit and open up my task sequence. And now I have my table defined orders QTY, orders times quantity, and then update from this. And now here's where I'm going to go back in and check these, because sometimes the task sequences are a little finicky for the update, but that one does appear to be updated. So now go back to my planning and create plan. And now again, now we see our processes are longer, so that I'm going to just assume that those values are correct. And of course, this is something we should go in and check. I should go in and check these values and make sure that I have 10 times that time and so on. I'm not going to do that right now. What I am going to do though is go back in and say, well, let's just add another order. So let's add order 002. And we'll make this for module, I don't know, let's make this for module C. And we'll have 5 of these. And we won't worry about its due date either. And now I can go back in my planning, create my plan, and now I should see 2 orders. And so we definitely see that. So we have a symbol here, finish 2. And one thing that we see here when I'm looking here immediately is I expect a symbol 2 to be used, right? So the order waited for a symbol 1 to finish. Same thing with finish. So we have 3 finish stations, but why didn't this one use it? Okay, so then we have to go back and debug. I think I know the answer to this. I think one thing I forgot to do is set all of the buffers to capacity 0. Of course, that's what I did. So for example, if you go to a symbol and say the buffer logic is infinity, and we're selecting using that overload function, then you have negative infinity for overload if you have infinite buffer capacity. And so that's why everything is going to go to the first one in the list. So we got to go back in, change that. Let's change that one to 0. And let's go back in and then update properties. Go back in and check my buffer logic. It's 0 there. And so again, hopefully you're seeing the benefit of having these custom objects is because I can just immediately update all of them. So now we go back to planning, and what I expect to see when I create the new plan is order 33 should jump in right here, and then we should see the same thing at finish. It should start at finish 2. So we create our plan, and let's see here. So we have a symbol 1. Yeah, so we have a symbol 1 and a symbol 2, exactly what we expected. Then finish 1. And finish 2, and so now the tasks are the transfer nodes are allocating using that overload function, and by setting the buffer capacities to 0, what we're really doing is looking at the available capacity. Capacities are 1 for all of these servers, so if one's busy and one's not, the one that's not busy is always going to get selected. So let's just do one more and make sure that we get that right with the finish. So I think we can do that. Let's go back in data. And let's do order 3. We'll make this module B, see if we can get all of them. And I don't know, let's make this 1. We'll make this a small order. And so now we go back in and plan and create plan. And now we can see finish 1, finish 2, finish 3 are all being used. So that selection was right. We only have 2 assembles, so one of them was going to have to wait here, as we see here if we looked at our constrained entities. And then, of course, we can look at the entity workflow if we want to look at it by order, where they went, and so on. So all of the kind of normal things that we do with the resource plan and entity workflow. Okay, so that's the end of this first video. I'm pretty satisfied right now. Of course, ordinarily I would do a lot more testing, and we will come back and do that when we finish up in video 3, where we add the things that we haven't yet covered, which are sequence-dependent changeovers and the bill of materials.